Okay, so we are going to look at some tables today, and they're only slightly different from the ones that you've done before. On the worksheet that you completed earlier, I gave you the words for the expression. In other words, I would say 6 increased by a number or something. This time, you're not going to have that, so you're going to have to figure out the relationship between the numbers on your own. Okay, so the first thing I want to do actually is talk a little bit about fact families. So fact families are really wonderful to know about when we're doing tables. They're really useful for all kinds of things, but they're especially useful for tables, and I'll tell you why in a minute. So here's what a fact family is. We'll start with 4, 5, and 9. We can make several equations out of 4, 5, and 9. So something plus 5 is 9. Well, we already know that's 4. 4 plus something is 9. We know that's 5. 9 minus something is 5. Well, it's got to be 9 minus 4 is 5 because the opposite of addition is subtraction. 9 minus something is 4. Well, that's got to be 9 minus 5 is 4. So what you're going to see here is that when we add the kind of the bigger number, then the unknowns are over here. Okay, we call those the add-ins, but you don't need to know that. And then when we're subtracting, the bigger numbers over here. And if I know, for instance, that 4 plus 5 is 9, then when I'm going backwards, I just ask myself which number is missing. So it's 9 minus 4 is 5. Okay, so the numbers are kind of like a set, and that's going to come in handy when we're doing tables, because sometimes we'll move in this direction of adding or multiplying, but sometimes you'll have the y value and you'll have to go backwards. And so fact families are really great to have in mind. Okay, let's look at another fact family. Here is a fact family with multiplication and division. So if I know that 3 times 5 is 15, then I just fill in the rest. So 3 times 5 is 15. And then something times 5 is 15. Well, I know that's a 3. 15 divided by, now remember, the opposite of multiplication is division. So to go backwards or to go the other direction, we need to divide. So 15 divided by something is 5. I'm going to call that a 3. And 15 divided by something is 3. And that's going to be a 5. Again, so if we've been moving in the right direction to the right, if we've been going from x to y and we've been multiplying, and now we see that we just have a y, and we have to go the other direction, we're going to do the opposite of multiplying. We're going to divide to go backwards. Okay, so that will come in handy and make more sense as we go. All righty, let's look at our first table here. And I can kind of scooch that back a little bit. Okay, so here's an x and a y. And on your worksheet, on your assignment, you're going to see things like this. And then you're going to see things like so then you're going to have to, from there, you're going to have to figure out what do those two things have in common. Okay, so if I put a 30 over here, and then I'll put my x right here. So let's look through this. How did I get from x to y? Remember, right here, I'm going in this direction. How did I get from x to y? Well, there's a couple of options here, right? So maybe I added 12 because 3 plus 12 is 15. So that can be my first guess. Now remember, with tables, the same rule has to apply all the way through the table. So if this set is connected by adding 12, then this one does too. So is 5 plus 12 equal to 25? Oh, no, it's not, is it? 5 plus 12 is 17. So that is not the rule for this table. Let's think of another possibility. What else might I have done to the 3 to turn it into a 15? There might be a hint right next to this table in gold. Well, another thing that I might have done is I might have multiplied it by 5. Let's see if that rule holds. 5 times 5 is 25. Yep, it is. Yay. Okay, I think we found the rule. So now we have to make sure that we can go the other direction as well, because now we have a y and we need to find the x. Now remember what I said. If you end up with the y and you need to find the x, do the opposite of what you've been doing. So what have we been doing? We've been multiplying by 5, multiplying by 5. So the opposite of multiply by 5 is divide by 5. So going the other direction, we're going to divide by 5. So 30 divided by 5 is 6. Okay. Last one, with my x here, and I need to write my expression, which is kind of what we do in this last box. The question is, what did I do to all these x's? Remember, these are all x's. These are possibilities for values for the variable. So what this is asking you is, no matter what number I put in my x box, if I put in 100 or 200 or negative 27, what am I going to have to do to that x to turn it into the y? Well, when we're going from the x to the y in that direction, what we did was multiply by 5. So how do we show multiply by 5? I think some people are still struggling with this, guys. We don't use x and we don't use dots. When we want to show multiplication in algebra, we just simply stick two things together. And with multiplication, the number, it's also called the coefficient, always comes first. So that shows 5 times x. X is a little bit wonky, isn't it? Let's try that again. 5x. Okay. All right, let's look at another table and see if we can make sense of this table. Okay. So what if I start here with a 2 and I end up here with a 16, and then I start here with a 5 and I end up here with a 19. Okay, and then I'm going to put a 23 right here, and right here I'm going to put an x. Okay, so let's see, what are the possibilities from moving from x to y? What might I have done to that 2 to turn it into a 16? Well, when we go from x to y, if the number's getting bigger, in other words, if the x is kind of small and the y gets bigger, then I know it's one of two things. We're either adding or we're multiplying, right? We're either adding or multiplying because it's getting bigger. So let's start with adding. What would I need to add to that 2 to turn it into a 16? Remember, one way to find out is if I know I want to add going from left to right, then what would I do from right to left? I would do the opposite, and I would subtract. So 16 minus 2 is 14. So that's a fact family, right? So 2 plus 14 is 16. 14 plus 2 is 16. 16 minus 2 is 14. And 16 minus 14 is 2. Okay, so you'll find that addition and subtraction are what we call inverse operations. They're opposites of each other. And that's what can make up a fact family and be super helpful. So I want to know, what am I going to add to the 2 to turn it into a 16? Well, an easy way to figure that out is to do the opposite and say 16 minus 2 is what? And it's 14. What would be the other option here? So we said if we're going from a little number to a big number, that means we're either adding or multiplying, as long as we're dealing with positives. So what would I multiply? 2 times what is 16? 2 times what is 16. Well, once again, an easy way to figure that out is to do the opposite. So instead of just saying 2 times what is 16, I can go the opposite. I can say 16, and the opposite of multiplication is division. 16 divided by 2 is 8. So that would mean that 2 times 8 would be 16. So now we just have to figure out which rule is it. Is it this one, plus 14, or is it this one times 8? Which one will make the next set of numbers true? I'm going to give you just a second to think about that. Is it plus 14 or times 8? How am I going to get from 5 to 19? All right. What do you think, guys? Is it plus 14 or is it times 8 that's going to get me from 5 to 19? Well, 5 plus 14, hey, it's 19. I think we might have found it. 5 times 8 is 40, so that's not going to work. So now we know that our rule is plus 14. So whenever I have an x value, to get to the y value, all I do is add 14. Okay, but now they're giving us a 23 in the y value. So if my rule in this direction is to add 14, what would my rule be in this other direction? In other words, what's the opposite of plus 14? The opposite of plus 14 is to subtract 14. So 23 minus 14 is 9. Okay. All right. So once again, the last question is to basically figure out what did we do to the x, and that's going to give us our expression. So what did you do to this x to turn it into the y? Well, we added 14. What about this x? Same thing. What about this x? Same thing. So we took all those x's and we added 14. And that, my friends, is the rule to that table. Okay, so I hope this has helped you maybe get a little bit more clarity on the whole working backwards thing. Know that if you're working from left to right and you're multiplying, then in the other direction, it will be division. Know that if you're working from left to right and you're adding, in the other direction, it will be subtraction. Okay, all righty.